Good afternoon, everyone, and welcome back to the first night Moss Landing Marine Lab seminar series. My name is Max Grand. I am from the Chemical Oceanography Lab, and I'll be your host this afternoon. Before I get started, I need to remind you with regards to the rules of the road for our seminar series. So please bear with me as I read through those rules. Remember that all the audience participants will be muted throughout the seminar. Please do not attempt to turn on your video or share your screen during the talk. And remember that there will be an opportunity for the audience to ask questions live at the end of the talk, just like in a normal seminar. So once the speaker has finished their talk, you can use Zoom raise hand feature to notify the meeting host that you'd like to ask the speaker a question. And the raise hand feature is located under the participants tab at the top of the Zoom window. And that's pretty much it for the rules of the road. So it's my pleasure to introduce our seminar speaker this week, Dr. Edem Mahu from the University of Ghana. Dr. Mahu received her bachelor's in oceanography and fisheries from the University of Ghana and her PhD in oceanography with an emphasis in geochemistry, also from the University of Ghana. And Edem is actually quite familiar with Moss Landing because she came to Moss Landing Marine Labs in 2010 through the International Student Exchange Program in order to complete her master's thesis research with Kenneth Cole and also Nick Welchmeyer. And while there at that time, she used the fluorescein diacetate method to study the impacts of all contaminations in nearshore environments. So from what I understand, what she did is to use oil from the Deepwater Horizon spill, and she used that oil to spike some sediments from Elkhorn Slough to look at the impact on biota. And then Dr. Mahu returned to Moss Landing, this time to conduct her PhD research with Kenneth and Ivano. And this time she came back with a bunch of sediment cores from several estuaries in Ghana. And she dated her cores, she performed mineral analysis and trace mineral concentration to investigate the provenance and determine whether these sediments are contaminated with heavy metals. Dr. Mahu is now a lecturer in the Department of Marine and Fisheries Sciences at the University of Ghana. She's also an affiliate member of the African Academy of Science and a trustee within the Partnership for Observation of the Global Ocean, also known as POGO. Dr. Mahu has published numerous papers in high-impact journals, and she has received several awards, and I won't have time to go through all of them, but I'd like to note that she recently received the Flair Fellowship from the African Academy of Science and also the Royal Society. And I think you could say that Edem is really a multidisciplinary scientist. She's done a lot of work in terms of heavy metal toxicity in aquatic systems. She's done some work in terms of microplastics in the Gulf of Guinea, also ecotoxicology work, and she's also interested in various aspects of paleoceanography. And before we get started, I'd like to remind everyone that Edem is currently in Ghana, and it's 11 p.m. in Ghana right now. So I think we owe Edem a round of virtual applause for giving a seminar at such an ungodly hour. So please take it away, Edem, whenever you're ready.
Thank you very much, Max, for the kind words. Good afternoon, everyone. Once again, it's such a great pleasure and honor to actually be with you today, 7 years after leaving Moss Landing Marine Laboratories. For me, I think that this is really a good, this is good. And I want to thank you all for giving me the platform to present some of the research that I've done in the past in the Gulf of Guinea to the Moss Landing Marine Laboratories community. This evening, I'll be talking on ocean health and seafood safety in the Gulf of Guinea. Okay. All right. So, yeah. So I'm sure a lot of us will be wondering where Ghana is and where the Gulf of Guinea is. So I just brought a map here to actually show where the Gulf of Guinea can be located in Africa and where Ghana actually is positioned within the Gulf of Guinea. So the Gulf of Guinea is actually an area of a coastal water body that is bounded or bordered by about 16 African countries, right from Angola all the way to Liberia. Now, Ghana is actually one of the countries that forms the Gulf of Guinea, and today's talk is actually going to focus on studies that have been carried out in Ghana. Now, the problems or the environmental issues that actually confront this region is not too different when you move from one country to the other. We all face the same challenges. So it is very likely that when you do a research in the region, the results that you find, for example, on heavy metals, should not be too different from what you find in Ghana, would not be too different from what you find in Cote d'Ivoire or even in Nigeria. Now, Ghana has an area of about 238,540 square kilometers. And as I said already, it's located within the Gulf of Guinea. It has a total boundary length of about 2,633 kilometers, out of which 560 kilometers constitutes the coastline. So that is why, as a country, we have an interest in oceanography. Even though I would say that oceanography is still developing, it's still burdened in the region. We are not that advanced. Because we have a boundary with the ocean, we seem to have that interest in ocean sciences. Ghana has an exclusive economic zone of about 225,000 square kilometers. And so it's interesting to note that the Ghana seaward boundary is actually even bigger than its landward boundary. So for us, we place a lot of value on the ocean. Now, the Gulf of Guinea as a region is confronted with several environmental challenges. Key among these challenges is pollution. And when I talk about pollution in the region cuts across various areas. So we have heavy metal pollution, we have plastic pollution, we have pollution that is associated with agricultural activities. And then another problem that the region also faces is our declining fish stocks. Ghanaians, and for that matter, most of the countries within the Gulf of Guinea actually consume more fish as protein than any other protein. So when you take the diet of countries within the Gulf of Guinea, most of them have a fish diet constituting about 60% or even more of their protein. So we place a lot of value on what is coming from the sea. Other challenges are environmental degradation. So that picture that we are seeing right there is trucks that are, mining soil or beach sand that will be used for construction work on land. And also, we also have challenges with the cutting down of mangroves. So a lot of our mangrove forests have also been degraded because there are people who actually cut these mangroves and use them for firewood. Then also we have the issue of sea level rise and erosion. So this problem or challenges actually are challenges that persist within the region, they cut across. So we all have one goal to address these challenges as countries within the region. Now, today my presentation is going to focus on heavy metal pollution. So one may ask, why is heavy metal such a huge challenge or a big problem within the region? Now, first of all, it is worth noting that Ghana or West Africa is one of the biggest e-waste hub for the Western world. So if you may care to know, a lot of the used electronics from Europe and of course America end up in Ghana and some other countries within the region. And so we have this electronics being dumped, when it comes to Ghana, the area where you find them is actually a place that is very close to the sea. We call it Agbogboshi. And we have people who are trying to refine these metals, people burn these metals, and in the process of refining and doing all that, we have leachates that go into the coastal environment. There are also health implications that are associated with this activity. Then, of course, we also have the issue of illegal mining of gold. So galamsey, as we call it locally here, is a term that we use in describing the activity of mining gold illegally in Ghana. Ghana's biggest export is actually gold. Most of the country is sitting on gold, and so we have the formal sector, or the formal gold mining sector, and we also have the informal gold mining sector. Now, what happens in the informal gold mining sector, or the artisanal gold mining sector, which actually forms the chunk, about 70% of the gold mining sector, is that we have local people, or the indigenous communities, coming together to mine gold using very toxic elements, especially mercury, to get gold from the soil. And then once they do that, there is no way of neutralizing whatever effluent is coming or is associated with the gold that they are mining with mercury. So all this mercury actually ends up in the environment. And it's also worth noting that Ghana's gold is also associated with arsenic. And so once they take out the gold, the arsenic also, finds its way into the environment. So when you look at, when you come into the coastal environment, arsenic and mercury, tend to be a huge problem as far as heavy metal pollution is concerned. Then, of course, we also have industrial activities. So when you come to the middle belt of the country, this is where we have all the huge industries. A lot of these industries, even though they are mandated to sort of treat their effluent, most of them do not do it. So they end up, discharging their effluents into the environment. And this also has implications for the coastal ecosystem. So therefore, there's the need to, fully characterize this problem. Now, earlier I stated that oceanography is a problem that is an area that is still burdened in Africa. And so we tend not to have the technology and all that to do a lot of the advanced work that is being done elsewhere. So while in North London, while in the University of Ghana in 2009 to do my master's, I got an opportunity to actually, go to the US through the ICEP program to do my research work and also take some coursework there. And so while I was looking through schools and all that, I came across San Jose State University, and then I, did a few searches, and I got to know Professor Kenneth Cole, who was very happy to accept me into his lab in Moss Landing Marine Laboratories to, do a piece of a more advanced work on samples that I brought from Ghana. So while in Moss Landing, I met very nice and fine people. I cannot mention all of them, but I must say that everyone at Moss Landing was very warm and receptive, and that made my stay there really comfortable. I met Professor Kenneth Cole, who was my first point of contact in Moss Landing Marine Laboratories, and his home, his lab was so receptive to me, and he was a nice person. He was really nice to me. And then I met Professor Ivano Aiello, who happened to also be my geological oceanography lecturer. But when I got back to Ghana, I had to teach geological oceanography, and thanks to the foundation that I got from Professor Aiello, I was able to teach the course with no difficulty at all. And of course, Jim Harvey, who played a key role with my statistics, quantitative and marine biology, was also very nice. And Professor Nick Welshmeyer and Dr. Samuel Holmes. All these people actually made my research stay in Moss Landing really, really great. So now back to the research objectives. So the first objective was to reconstruct heavy metal pollution history in Ghana using sediment cores from 6 Ghanaian estuaries. Now, why is this relevant? Or why the need to reconstruct the heavy metal pollution? As a country, we don't monitor our water bodies. We don't collect time series data, or yeah, if I may put it, on issues like this. And so the data is not even there. The preliminary data, the baseline data is not there to compare to, and to know how your ecosystem is doing and all that. So there was that need to actually go back into the past to see how the environment was before and how it had changed through time. And so because of that, I took 6 sediment cores all the way spanning across the entire length of Ghana from 6 estuaries, and then brought them to Moss Landing Marine Laboratories to do this kind of study. And then the second objective was to model the ecotoxicological risks that were associated with the heavy metal pollution in the estuaries using the aqua risk model. Okay, so to reconstruct the heavy metal pollution history in the estuarine sediments from Ghana, we estimated the sedimentation rates and ages of the sediment core from each estuary using the constant rate of supply model. And we validated that with a constant initial, constant concentration model. And then with that, we were able to evaluate the temporal changes in metal concentration in each estuary during the last 100 to 200 years. And also, I also brought surface sediments that were taken aboard the fridge of Nansen. These were sediment samples that were taken off the shelf of Ghana. So I brought those sediments, and we also compared what we were getting in the estuaries, what was on the shelf, to see if indeed the land-based activities were actually, going that far into the sea. So the study areas, as I mentioned earlier, I took sediment samples from 6 estuaries that spans the entire length of Ghana. So the Ankobra estuary and the Pra estuary, the Emisa, the Densu, Sakmotu, and also the Volta estuary. Now, Ghana's coastline is divided into 3 zones. So we have the western coast, we have the central coast, and then we have the eastern coast. And so the eastern coast, each of these zones have peculiar problems. So when you move to the western coast, the most challenging issue there is the issue that I talked about, the illegal mining activities. And also there's a lot of farming activities there. So there are other issues like nutrient pollution and all that. And then when you move towards the middle belt, also we do have some mining activities going on in the inland areas of this side of the coast. And then coming to the eastern coast, this is where we have the industrialization. We have a lot of industrial activities taking place on the coastline. And as I mentioned earlier, I also took samples across the shelf. So moving from a depth of about 25 meters all the way to about 90 meters, 1,000 meters above the fridge of Nansen. So these sediments were also brought to the laboratories. Okay, so what are some of the results, or what are some of the things that we found? The first one was the excess lead-210 activities in the core. So the excess lead-210 activity actually helped in the estimation of the sedimentation rate. So over here we have all the 6 estuaries which I have labeled from A to F, having some excess lead-210 activity, which means that they are very suitable. You can use them to reconstruct the past metal, or reconstruct, we can age date these sediments. So from this excess lead-210 activity, we were able to estimate the sedimentation rate across the various estuaries. And in summary, we got very high sedimentation rates for the Volta estuary, for example, and then we got very low sedimentation rates for the Ankobra and the Sakmotu estuary. So with this sedimentation rates, we controlled the cause, and based on that, we were able to date all the 6 cores. So when you take the core from Ankobra, for example, we're able to date it for up to about 140 years. With the lead 210 dating method, you can date up to 200 years because of its half-life. So we're able to date up to about 140 years for the Ankobra estuary. The Pra were able to go as far as up to about 60 years. And then for the Volta estuary, also we're able to go as far as about 100 years for that estuary as well. So basically, we're able to date all these 6 estuaries, and this was very novel for Ghana because this was the first time that such a study had been carried out that goes back into the history to know what has happened in the past. So with that, we were able to, we also did an analysis of the sediments. We did a geochemical analysis on the sediments. We looked at the heavy metal profiles using the ICPMS at Moss Landing Marine Laboratories. And with that, we were able to actually look at the profiles, the heavy metal profiles, based on the depths and the years of the various cores. So for example, for Ankobra estuary, it will be interesting to note that the levels of mercury and arsenic were very, very high. When we go to the next results, we look at the enrichment factors, which actually gives us even a clearer picture of how much these metals have gone beyond the background levels. Again, for the Pra estuary, which is also in the western coast, where we have a lot of gold mining and all that, again, we found that arsenic and mercury were very high. They were beyond the background geochemical levels. And then coming to the central coast, we saw a decrease. So gradually, as we move from the west to the east, we saw a decrease in the level of arsenic, but still there was significant amount of arsenic. There was some amount of arsenic, but it's not as significant as what we found in the Ankobra estuary. The Ankobra estuary, arsenic values were ranging from about 95 micrograms per gram to about 105 micrograms per gram, which was, far more than what is expected to be in the sediment. And then as we move our way further, we see a decrease in these elements. However, we saw that other elements like lead and cadmium, their levels were going up. And this is because these areas actually fall within the industrial zone of Ghana. And mostly the industries that we have in this area, some of them are smelting industries that release a lot of byproducts into the environment. And so when you move away from the mining areas, you tend to find high levels of cadmium, lead, and zinc in these areas. And then finally, when you look at the Volta estuary also, now the Volta estuary was actually one of our cleanest estuary for this region for this study compared to the other estuaries, because the levels were not that high. However, we found, 2 strong peaks for mercury in the cores from this estuary. The Volta estuary is very big, actually takes its source from other rivers in the region. So it's not just Ghana, it takes its source from Burkina Faso And so it's not just, so we actually felt that maybe this year, between 2005 and 2000, something could have happened in the upstream regions of these rivers. That was why we were seeing this huge peaks. But apart from this peak, the levels were actually okay. So do the profiles depict pollution at all? To understand or to know whether there was pollution in these environments, we needed to look at the enrichment factors. So the enrichment factor actually gives us an idea of how enriched the metal is beyond what is expected, or the background geochemical level. And so we found that, again, Wankobra estuary, when you look at mercury, for example, you see that mercury was highly enriched in the sediment. And of course, this is expected because, as I already said, there's a lot of mining activities going on there with the metal mercury. And then arsenic, of course, was also highly enriched. And then when you come to Pra, you find the same problem, enrichment of mercury and arsenic. And then the same thing also happening in Emisa estuary, which is in the central coast. And then when you come to the eastern coast, you find metals such as lead, copper, cadmium having very high enrichment values over the years. And we actually started seeing some good trends. So we see that the enrichment is actually increasing over recent times. The same thing is also seen for the core from the Sakmona estuary. The Sakmona estuary actually happens to even be a Ramsar area, but as I speak with you now, the estuary is no more as clean as it used to be. It's no longer an estuary because there's just too much modification of the watershed. There's a lot of pollution happening. And so the estuary has lost a lot of its values that it used to have in the past. And then, of course, we also have the Volta estuary. But over here, we didn't see that much enrichment in the metals compared to the other ones. And, we also looked at the flats, the excess flats. So basically how much metal is, coming into the estuaries. So you see that, interestingly, we saw some nice trends for the Emisa estuary, for example. You can see that over time, the metal levels are just increasing. And of course, for the Sakmo-2 estuary, you can see clearly that the metal flats into the estuary is just building up over time. So comparing what we found in the estuary to the shelf sediments, you can actually see that the levels that we found, especially at the mouth of, or at the shallowest depth, are not too different from what we were seeing in the estuary. And let me clarify that this was taken from the western coast. These shelf samples were taken from the western coast. So we compared this to the samples from the Ankobra estuary, which was in close proximity to the samples that were taken from the shelf. So we didn't see that much difference in the level. So it tells us that yes, the levels that we are finding in these estuaries are actually going into the coastal environment, and this has implication for the fisheries and other ecosystem processes. So the next thing was to look at any ecotoxicological risks that are associated with the heavy metal pollution in each of these estuaries. So we use the aqua risk model to do what we call a hazard screening of each of the metals. So what the aqua risk model does is that it uses a three-tiered approach to sort of characterize an element as to whether it poses risks to the ecosystem or not. So the first tier will do what we call the hazard screening, where it will take out or eliminate metals of potential concern. So metals that have the potential to impact or have the potential to cause adverse effects, you take them and then carry them further into the next stage of the risk assessment. Then once you move from the hazard screening, it does what we call the site-specific modeling, where you use those response data to sort of model to see, to come out with the acceptable criteria for protecting species within the estuaries. And then the last thing that we also did was to generate risk maps for each of the estuaries based on the metals of potential concern that was identified in each of the estuaries. Okay, so as I said, so to do the risk assessment, we had to take surface sediments. So this time around, we went back to these estuaries and we took surface sediments from three of the estuaries. So the Ankobra estuary, the Sakmotu estuary, and also the Volta estuary. Now this was to also represent the geographical partitioning of the coastline. So the Ankobra estuary again is to the western coast. Then we have the Sakmotu estuary, which was in more proximity to the industries. And then we have the Volta, which was not that much polluted with the heavy metals. Okay, so what did we find? So this were the risk maps, this were the probability distributions per the sediment quality guidelines that we put into the software. So here, basically what it's telling us is that anything that falls before the green line means that it's safe, it's not of concern. And so for the Ankobra estuary, we realized that copper, cadmium, zinc, and lead were not of concern to the estuary or to the ecosystem. However, mercury and arsenic, as you can see below, actually fell within or even above the sediment quality guidelines, which tells us that these are metals of potential concern in this estuary. When you look at the Sakmotu estuary, also we found that yes, metals like copper, cadmium, and lead, arsenic, were all beyond the sediment quality guidelines, apart from mercury and zinc, which were below the sediment quality guidelines. And then finally, for the Volta estuary, we saw that all the metals were safe. Actually, there were no identified metals of potential concern within the estuaries. So the next thing was to generate the risk maps for these two estuaries, so the Sakmotu and the Ankobra estuaries, which had metals identified as metals of potential concern. So we wanted to see which part of the estuary is actually safe and which part is not safe and all that. For the Ankobra estuary, we had the first risk map is for arsenic. We saw that yes, arsenic is actually ubiquitous. We find it in all the estuary, but the problem or the levels were very high when you move towards the mouth, when you move towards the head of the estuary. And also, when you look at mercury, you'll see that the levels of mercury were really low within the estuary, but they were more higher as you move to the head of the estuary. Again, this also gives us an idea of the source of the metal within the estuary. It tells us that mostly the metals are coming from upstream region, which most likely is from the gold mining activities. Okay, the next map is the Sakmo-2 estuary. For this one also, with the metals that were identified as metals of potential concern were cadmium, mercury, copper, and lead. And interestingly, we note here that the metals, the highest risk areas actually, apart from cadmium, the highest risk areas for all the metals actually spreads across the estuary. And this really depicts what happens, or what is happening in the watershed of the Sakmo-2, because this lagoon is actually sorry. So this cuts across the source of the metal, or the source of this metal pollutant actually cuts across, because that is what depicts exactly what the Sakmo-2 estuary looks like. It's surrounded by industries. So the metals are coming from various sources. A few publications. So we were able to publish a few papers from this research. The first of it was what we published in Marine Pollution Bulletin, Distribution and Enrichment of Trace Metals in Marine Sediments from the Eastern Equatorial Atlantic Ocean of the coast of Ghana. And then we also published one in Estuarine Coastal and Shore Science on the geochronology. And we also did one on provenance, which was also published. And then the probabilistic risk assessment that we also did, we also happened to also publish that as well. Currently, well, I want to also talk a bit about what I'm doing at the moment. So as Max rightfully said, I've become a multidisciplinary researcher, because at the moment I am doing quite a number of different researches. So the prominent amongst them is my Future Leaders African Independent Research Fellowship Grant from the Royal Society, from which I am trying to use stable isotopes of oyster shells to reconstruct past climate. So again, here I'm going to look at the past pH, past temperature, and also environmental change, including heavy metal pollution levels in the Gulf of Guinea. Now, this project is actually looking at 4 different countries in the region. So it's not just Ghana, but I'm also working in Benin, Sierra Leone, and Nigeria. Then I also have a watershed management, nutrient management project that is also ongoing from the Organization for Women from the Developing, Women in Sciences from the Developing World. It's called the OWSD Early Career Grants. And with that, one is an applied science. So what I'm doing is coming out with sediment testing, soil sediment testing kits to be given to farmers to sort of guide them in the use of nutrients around farmlands within the Keta Lagoon, which currently is undergoing some hypoxia. And then there's also a project that I'm leading, which is the BIOTA. BIOTA is an acronym for Building Capacity in Ocean Acidification in the Gulf of Guinea. This project is also being done or being conducted among 5 countries within the Gulf of Guinea. And what we are doing is to start an ocean acidification monitoring project within the region. So we are building capacity in this area, and then from there we will set up ocean acidification monitoring stations within the region where we can collect data on OA in the region. I'd like to thank the International Student Exchange Program for actually giving me that opportunity to come to Moss Landing Marine Laboratories, and then of course to Moss Landing Marine Laboratories for hosting me, especially my supervisors. And I must also mention that the United States Geological Survey in Santa Cruz actually was the lab that helped with the Ledge 210 dating of the sediments. I also got some funds from the International Foundation for Science to do the risk modeling. And then the CSU Coast, I also got some funds from there, as well as the H. Thomas Harvey Research Fellowship, which actually helped me to carry out my fluorescent diacetate assay research. And with that, I would like to thank you all for tuning in to listen to my talk today.
Well, thank you very much, Edem, for a wonderful talk. I forgot to mention as well that we'll be hosting a virtual happy hour after the Q&A session. For those of you who would like to chat with Edem a bit more informally, we'll leave the Zoom session open. And the floor is now open for questions. So remember, if you would like to ask a question, please raise your hand and we'll unmute you to ask your question. Okay, I don't see any questions so far, so I'll ask one just to motivate everyone to ask some maybe. Edem, I was looking at your enrichment factors for all those metals in those Ghanaian estuaries, and I was wondering what kind of background geochemical concentration did you use to put together those enrichment factors?
Yeah, so we normalized them to Goa 1960, no, yeah, for continental shelf sediments.
Okay.
Yeah.
Okay, okay. Any other questions from the audience? Oh, Kenneth has a question. Oh, I guess I'll unmute Kenneth and go ahead, Kenneth.
Yes, can you hear me now?
Yes.
Edem, Susan and I very much enjoyed your talk, and it's amazing how much you got out of such a short time with us. It was great to hear from you, and we are very impressed by how far you've gotten from such a short trajectory. Regarding your talk, your hazard assessment was specific for sediment concentrations, and I'm wondering how you extrapolated those into impacts on fisheries. Maybe you could talk a little bit about that. And so nice to hear your children in the background.
All right, okay, yeah, so because of time constraints, I couldn't present data on fisheries, but what we did was, so from the hazard or the risk assessment with the sediments, what we did was to take, for the dose response data, you have to use invertebrates to do that. And those have a link to the fisheries because when you take the food chain, some of these fishes will feed on the small invertebrates, and then it moves up the food chain. And also, we also have the issue of bioaccumulation and biomagnification, so as you move up the food chain. But we have actually also measured levels of the metals in fish from the Gulf of Guinea, from Ghana to be precise, and we have found the same picture that we are seeing in the sediments. So we have found very high levels of arsenic in certain fish species, especially the demersal fish species like the shrimps, the crustaceans. We have found very high levels of arsenic and mercury in these fishes. And this, still reiterates the fact that arsenic and mercury are actually a problem in our waters. So I couldn't present that with results also because I felt that there was going to be too much to be showing for the time that I was given. But yes.
Okay, yeah, fair enough. I appreciate the time constraints. I'd like to point out to the audience listening that Edem represents something of a champion in geochemistry in Ghana, not only as a exceptional scientist, but one who has been able to incorporate her academic career and have a family and gain international recognition for her work. And we couldn't be more proud. Thank you, Edem, for a great presentation.
Thank you so much, Kenneth. I must say that I owe a lot of this to you and your family because you gave me that platform, and I still remember that recommendation letter you wrote for me. So for all of you here, I have been in touch with Kenneth. A lot of my grants, the FLAIR, the OWSD, I always ask Kenneth to write recommendation letters for me. And some of these letters, actually, I have to submit them to the funders myself. So I see the candid, opinions that he presents about me, how I started, how I came to Moss Landing. As I mentioned earlier, Ghana is still not developed when it comes to ocean sciences. We are not that advanced. And so a lot of the things that I am doing today was because of the good foundation that I got in the chemical oceanography lab. The time that Kenneth had for me, each time I come to him, he's always open to me and all that. That is what has actually given me that ground or that firm foundation, whatever I'm doing today. So I owe it all to Kenneth. I'm so grateful. I am very happy that you are here with Susan and the whole family to actually support me, to encourage me. Thank you so much.
Yeah, so I would suggest that your intellectual capacity had something to do with it. So, maybe ours was an opportunity, but you really shined. So appreciate that, and good luck in the future.
Thank you. Thank you.
Thanks,
so much.
Kenneth and Edem. We do have another question from Dimitris. I'll unmute you right now.
Oh, hi, Edem. Hi. And I think Brian also has a question. He's raised his hand. I can see that on the list, but I'll ask mine first. Do you have any plans for, or first of all, does estuary circulation matter? And do you have any plans to carry out any sort of modeling would that be helpful?
Yes, estuarine circulation actually counts when it comes to metal distribution within the estuaries, and even exported when it comes to the export of metals into the shelf, the continental shelf. There are plans to do that. Actually, Emily Schroyer, who is at Oregon State University, together with Emily, we put together a proposal that is going to look at the circulation within estuaries in Ghana. Even though that is to heavy metals, we would, we can use that information to actually understand how the metals are being distributed within the estuaries. I don't know if that answers your question, Demetrius.
Okay, we do have another question from Brian as well. So Brian, go ahead.
Hi, everyone. I don't have a question about the science because I'm a physical oceanographer, not in chemistry. But I would just like to add to the praise of Edem that Kenneth gave. I work with Edem on a few different capacity development projects in Ghana, and she is a real leader in developing oceanography in Ghana. She's a sensational partner in these projects. I just wanted people to hear that.
Thank you, Brian. Do we have any other questions for Edem before we move to the happy hour session? I'll give you guys 1 minute or so.
Max?
Yes?
Can I say something briefly? Yes. So yes, Brian and Dimitris are actually collaborators, and I'm sure a couple of other people from the capacity development program that he's talking about are also here listening to this talk. So we have a coastal environment ocean summer school in Ghana that actually has instructors from various universities across the US. We have Brian, who is actually the leader. He actually came up with this idea and all that from Michigan University. We have Oregon State, we have Woods Hole, people from all over the place. So we are looking at expanding the school. The goal of the school is to build capacity in oceanography in Africa. We want to increase the representation of African scientists in oceanography when we go for international meetings. And so we are still throwing invitation to a lot of people. I was telling Max this afternoon that we don't have anybody from Moss Landing taking part in that school. So yes, if you are interested, if you want to be part of the summer school on coastal ocean environment in Ghana, please don't hesitate to email Brian Albick or send me an email on that. And we are happy to get you involved. Thank you.
That sounds wonderful, and I'll make sure I'll pass this around to all the other faculty at Moss Landing as well. It sounds like a great